This article refers to the archive file format. For the physical device that read and wrote zip disks, see zip drive. Zip is an archive file format that supports lossless data compression. A zip file may contain one or more files or folders that may have been compressed. The zip file format permits a number of compression algorithms. The format was originally created in 1989 by Phil Katz, and was first implemented in PKWARE, Incorporated's PKZIP utility, as a replacement for the previous ARC compression format by Thom Henderson. The zip format is now supported by many software utilities other than PKZIP. Microsoft has included built-in zip support in versions of Microsoft Windows since 1998. Apple has included built-in zip support in Mac OS X 10.3 and later. Most free operating systems have built-in support for zip in similar manners to Windows and Mac OS X. Zip files generally use the file extension zip, or zip, and the My Media type application zip. Zip is used as a base file format by many programs, usually under a different name. When navigating a file system via a user interface, graphical icons representing zip files often appear as a document or other object prominently featuring a zipper. History: the zip file format was created by Phil Katz of PKWARE. He created the format after his company had lawsuits filed against him by Systems Enhancement Associates claiming that his archiving products were derivatives of SEA's ARC archiving system. The name zip was suggested by Katz's friend, Robert Mahoney. They want to imply that their product would be faster than ARC and other compression formats of the time. The earliest known version of zip file format specification was first published as part of PKZIP 0.9 package under the file app Node.txt in 1989. The zip file format was released into the public domain, but some zip features are covered by patents or pending patents. Version history: the zip file format specification has its own version number, which does not necessarily correspond to the version numbers for the PKZIP tool, especially with PKZIP 6 or later. At various times, PKWARE has added preliminary features that allow PKZIP products to extract archives using advanced features, but PKZIP products that create such archives are not made available until the next major release. Other companies or organizations support the PKWARE specifications at their own pace. The zip file format specification is formally named AppNote Zip File Format Specification, and it is published on the PKWARE.com website since the late 1990s. Several versions of the specification were not published. Specifications of some features such as BZIP2 compression, strong encryption specification and others were published by PKWARE a few years after their creation. The URL of the online specification was changed several times on the PKWARE website. A summary of key advances in various versions of the PKWARE specification. 2.0 file entries can be compressed with deflate and use traditional PKWARE encryption. 2.1 deflate 64 compression, 4.5 documented 64-bit zip format. 4.6 BZIP2 compression, 5.0 DES, triple DES, RC2, RC4 supported for encryption, 5.2 AES encryption support, corrected version of RC2-64 supported for encryption. 6.1 documented certificate storage. 6.2.0, documented central directory encryption. 6.3.0, documented Unicode file name storage. Expanded list of supported hash, compression, encryption algorithms. 6.3.1, corrected standard hash values for SHA-256512. 6.3.2, documented compression method 97. 6.3.3, document formatting changes to facilitate referencing the PKWARE application note from other standards using methods such as the JTC1 referencing explanatory report as directed by JTC1/SC34N1621. WinZip, starting with version 12.1, uses the extension ZIPX for zip files that use compression methods newer than deflate. Specifically, methods BZIP, LZMA, PPMD, JPEG and WAVAC. The last two are applied to appropriate file types when best method compression is selected. Standardization. In April 2010, ISO/IEC JTC1 initiated a ballot to determine whether a project should be initiated to create an ISO/IEC international standard format compatible with ZIP. The proposed project, entitled Document Packaging, envisaged a ZIP-compatible minimal compressed archive format suitable for use with a number of existing standards including Open Document, Office Open XML and EPUB. In July 2010, the ballot for initiating this project failed to pass an international vote and was rejected through ISO/IEC JTC1/SC34N1461. Comments against this project cited the recognition that an existing published work on the ZIP format has been in existence for over 18 years in the form of the PKWARE app note, recommending instead for JTC1 to approve the ZIP application note as a referenced specification per Annex N of the currently published JTC1 directives. This ballot did approve a request for the formation of a study period for the purpose of seeking wider input regarding this core technology. The study period, which began in October 2010, brought together a number of international experts to discuss using ZIP within international standards. In March 2011, this group presented to JTC1 a new recommendation on how to incorporate ZIP within international standards. Acknowledging the broad interoperability that the ZIP format has achieved, the study group concluded in their recommendation that the best way to achieve our technical objectives is to have PKWARE continue its maintenance of the ZIP application note. The recommendations drafted by this study group were presented for balloting as ISO/IEC JTC1/SC34N1621 in July 2011 and was approved by an international vote. Proposal N1621 directs international standards that use ZIP to not duplicate or contradict the provisions of PKWARE ZIP application note, and to reference the ZIP application note's capabilities via an external normative reference to the latest version of the ZIP application note. Standards using ZIP should include a JTC1 referencing explanatory report when referencing the PKWARE application note. A provision of N1621 included an option for drafting a profile standard for referencing ZIP. This profile could be used by other international standards that use ZIP to avoid having to write their own OER document where similar use of ZIP may exist. At this time, no standards that use ZIP have requested this profile. There is a new proposed standard in ISO/IEC JTC1 standardization process under the name ISO/IEC NP 21320-1, Information Technology, Document Container File, Part 1, Core. A preparatory draft of the text is available as a public document. Design. ZIP files are archives that store multiple files. ZIP allows contained files to be compressed using many different methods, as well as simply storing a file without compressing it. Each file is stored separately, allowing different files in the same archive to be compressed using different methods. Because the files in a ZIP archive are compressed individually, it is possible to extract them, or add new ones, without applying compression or decompression to the entire archive. This contrasts with the format of compressed tar files, for which such random access processing is not easily possible. A directory is placed at the end of a ZIP file. This identifies what files are in the ZIP and identifies where in the ZIP that file is located. This allows ZIP readers to load the list of files without reading the entire ZIP archive. ZIP archives can also include extra data that is not related to the ZIP archive. This allows for a ZIP archive to be made into a self-extracting archive, by prepending the program code to a ZIP archive and marking the file as executable. Storing the catalog at the end also makes possible hiding a zipped file by appending it to an innocuous file, such as a GIF image file. The ZIP format uses a 32-bit CRC algorithm and includes 2 copies of the directory structure of the archive to provide greater protection against data loss. Structure. A ZIP file is correctly identified by the presence of an end-of-central directory record which is located at the end of the archive structure in order to allow the easy appending of new files. If the end of central directory record indicates a non-empty archive, the name of each file or directory within the archive should be specified in a central directory entry, along with other metadata about the entry, and an offset into the zip file, pointing to the actual entry data. This allows a file listing of the archive to be performed relatively quickly, as the entire archive does not have to be read to see the list of files. The entries within the zip file also include this information, for redundancy, in a local file header. Because zip files may be appended to, only files specified in the central directory at the end of the file are valid. Scanning a zip file for local file headers is invalid, as the central directory may declare that some files have been deleted and other files have been updated. For example, we may start with a zip file that contains files A, B and C. File B is then deleted and C updated. This may be achieved by just appending a new file C to the end of the original zip file and adding a new central directory that only lists file A and the new file C. When zip was first designed, transferring files by floppy disk was common, yet writing to disks was very time-consuming. If you had a large zip file, possibly spanning multiple disks, and only needed to update a few files, rather than reading and rewriting all the files, it would be substantially faster to just read the old central directory, append the new files, then append an updated central directory. The order of the file entries in the central directory need not coincide with the order of file entries in the archive. Each entry stored in a zip archive is introduced by a local file header with information about the file such as the comment, file size and file name, followed by optional extra data fields, and then the possibly compressed, possibly encrypted file data. The extra data fields are the key to the extensibility of the zip format. Extra fields are exploited to support the ZIP64 format, WinZip-compatible AES encryption, file attributes, and higher resolution NTFS or Unix file timestamps. Other extensions are possible via the extra field. Zip tools are required by the specification to ignore extra fields they do not recognize. The zip format uses specific 4-byte signatures to denote the various structures in the file. Each file entry is marked by a specific signature. The end of central directory record is indicated with its specific signature, and each entry in the central directory starts with a 4-byte central file header signature. There is no BOF or EOF marker in the zip specification. Conventionally, the first thing in a zip file is a zip entry, which can be identified easily by its local file header signature. However, this is not necessarily the case, as this is not required by the zip specification. Tools that correctly read zip archives must scan for the end of central directory record signature, and then, as appropriate, the other, indicated, central directory records. They must not scan for entries from the top of the zip file, because only the central directory specifies where a file chunk starts. Scanning could lead to false positives, as the format does not forbid other data to be between chunks, nor file data streams from containing such signatures. However, tools that attempt to recover data from damaged zip archives will most likely scan the archive for local file header signatures. This is made more difficult by the fact that the compressed size of a file chunk may be stored after the file chunk, making sequential processing difficult. Most of the signatures end with a short integer 0x4b50, which is stored in little-endian ordering. Viewed as an ASCII string, this reads PK, the initials of the inventor Phil Katz. Thus, when a zip file is viewed in a text editor, the first 2 bytes of the file are usually PK. The zip specification also supports spreading archives across multiple file system files. Originally intended for storage of large zip files across multiple floppy disks, this feature is now used for sending zip archives in parts over email, or over other transports or removable media. The FAT file system of DOS has a timestamp resolution of only 2 seconds. Zip file records mimic this. As a result, the built-in timestamp resolution of files in a zip archive is only 2 seconds, though extra fields can be used to store more precise timestamps. The zip format has no notion of time zone, so timestamps are only meaningful if it is known what time zone they were created in. In September 2007, PKWARE released a revision of the zip specification providing for the storage of file names using UTF-8, finally adding Unicode compatibility to zip. File headers: all multi-byte values in the header are stored in little-endian byte order. All length fields count the length in bytes. The extra field contains a variety of optional data such as OS-specific attributes. It is divided into chunks, each with a 16-bit ID code and a 16-bit length. This is immediately followed by the compressed data. If bit 3 of the general-purpose flags field is set, then the CRC32 and file sizes are not known when the header is written. The fields in the local header are filled with 0, and the CRC32 and size are appended in a 12-byte structure immediately after the compressed data. The central directory entry is an expanded form of the local header. After all the central directory entries comes the end of central directory record, which marks the end of the zip file. This ordering allows a zip file to be created in one pass, but it is usually decompressed by first reading the central directory at the end. Compression methods. The zip file format specification documents the following compression methods: stored, shrunk, reduced, imploded, tokenizing, deflated, deflate64, BZIP2, LZMA, WAVPAC, PPMD. The most commonly used compression method is deflate, which is described in IETF RFC 1951. Compression methods mentioned, but not documented in detail in the specification include PKWARE Data Compression Library Imploding, IBM TERS, IBM LZ77Z Architecture. Encryption. ZIP supports a simple password-based symmetric encryption system which is documented in the ZIP specification, and known to be seriously flawed. In particular, it is vulnerable to known plaintext attacks which are in some cases made worse by poor implementations of random number generators. New features including new compression and encryption methods have been documented in the ZIP file format specification since version 5.2. A WinZip-developed AES-based standard is used also by 7-Zip, XCED, and .NET Zip, but some vendors use other formats. PKWARE Secure Zip also supports RC2, RC4, DES, triple DES encryption methods, digital certificate-based encryption and authentication, and archive header encryption. File name encryption is introduced in ZIP file format specification 6.2, which encrypts metadata stored in central directory portion of an archive, but local header sections remain unencrypted. A compliant archiver can falsify the local header data when using central directory encryption. As of version 6.2 of the specification, the compression method and compressed size fields within local header are not yet masked. ZIP64, the original ZIP format had a 4 GB limit on various things, as well as a limit of 65,535 entries in a ZIP archive. In version 4.5 of the specification, PKWARE introduced the ZIP64 format extensions to get around these limitations, increasing the limitation to 16 EIB. The File Explorer in Windows XP does not support ZIP64, but the Explorer in Windows Vista does. Likewise, some extension libraries support ZIP64, such as .NET Zip, PKZIP and IO-Compress Zip in Perl. Python's built-in zip file supports it since 2.5 and defaults to it since 3.4. Java's built-in Java util zip supports ZIP64 from version Java 7. Android Java API still does not support ZIP64. Combination with other file formats, the zip file format allows for a comment containing up to 65,535 bytes of data to occur at the end of the file after the central directory. Also, because the central directory specifies the offset of each file in the archive with respect to the start, it is possible for the first file entry to start at an offset other than 0, although some tools, for example GZIP, will not process archive files that don't start with a file entry at offset 0. This allows arbitrary data to occur in the file both before and after the zip archive data, and for the archive to still be read by a zip application. A side effect of this is that it is possible to author a file that is both a working zip archive and another format, provided that the other format tolerates arbitrary data at its end, beginning, or middle. Self-extracting archives, of the form supported by WinZip and .NET Zip, take advantage of these. They are AX files that conform to the PKZIP app note.txt specification and can be read by compliant zip tools or libraries. This property of the zip format, and of the jar format which is a variant of zip, can be exploited to hide harmful Java classes inside a seemingly harmless file, such as a GIF image uploaded to the web. This so-called GIFAR exploit has been demonstrated as an effective attack against web applications such as Facebook. Limits: the minimum size of a zip file is 22 bytes. The maximum size for both the archive file and the individual files inside it is 4,294,967,295 bytes for standard zip, and 1-844-674-407-0955115 bytes for ZIP64. Proprietary extensions. Extra field. Zip file format includes the extra field facility within file headers, which can be used to store extra data not defined by existing zip specifications, and allow compliant archivers not recognizing the fields to safely skip the fields. Header IDs 0 to 31 are reserved for use by PKWARE. The remaining IDs can be used by third-party vendors for proprietary usage. Strong encryption controversy. When WinZip 9.0 public beta was released in 2003, WinZip introduced its own AES-256 encryption, using a different file format, along with the documentation for the new specification. The encryption standards themselves were not proprietary, but PKWARE had not updated app note.txt to include strong encryption specification since 2001, which had been used by PKZIP versions 5.0 and 6.0. WinZip technical consultant Kevin Kearney and Staffit product manager Matthew Covington accused PKWARE of withholding SES, but PKZIP chief technology officer Jim Peterson claimed that certificate-based encryption was still incomplete. To overcome this shortcoming, contemporary products such as PentaZip implemented strong zip encryption by encrypting zip archives into a different file format. In another controversial move, PKWARE applied for a patent on July 16, 2003 describing a method for combining zip and strong encryption to create a secure file. In the end, PKWARE and WinZip agreed to support each other's products. Ontario, 2004-01-21, PKWARE announced the support of WinZip-based AES compression format. In a later version of WinZip Beta, it was able to support SES-based zip files. PKWARE eventually released version 5.2 of the zip file format specification to the public, which documented SES. The free software Project 7-Zip also supports AES and zip files. When using AES encryption under WinZip, compression method is always set to 99, with actual compression method stored in AES extra data field. In contrast, strong encryption specification stores compression method in the basic file header segment of local header and central directory, unless central directory encryption is used to mask encrypt metadata. Implementation. There are numerous zip tools available, and numerous zip libraries for various programming environments. Licenses used include commercial and open source. For instance, WinZip is one well-known zip tool running on Windows, and WinRAR, ISAC, InfoZip, 7-Zip, PZIP, B1 Free Archiver and .NET Zip are other tools, available on various platforms. Some of those tools have library or programmatic interfaces. Some development libraries licensed under open source agreement are libzip and infozip. For Java, Java Platform, Standard Edition contains the package Java util-zip to handle standard zip files. The zip64 file library specifically supports large files and treats zip files using random access. And the Apache AND tool contains a more complete implementation released under the Apache software license. For .NET applications, There is a no-cost open-source library called .NET Zip available in source and binary form under the Microsoft public license. It supports many zip features, including passwords for traditional zip encryption or WinZip-compatible AES encryption, Unicode, ZIP64, zip comments, spanned archives, and self-extracting archives. The Microsoft .NET 3.5 runtime library includes a class system I/O packaging package that supports the zip format. It is primarily designed for document formats using the ISO/IEC International Standard Open Packaging Conventions. In Microsoft .NET 4.5 version added support for arbitrary zip archives within the framework itself. The InfoZip implementations of the zip format add support for Unix file system features, such as user and group IDs, file permissions, and support for symbolic links. The Apache Ant implementation is aware of these to the extent that it can create files with predefined Unix permissions. The InfoZip implementations also know how to use the error correction capabilities built into the zip compression format. Some programs do not and will choke on a file that has errors. The InfoZip Windows tools also support NTFS file system permissions, and will make an attempt to translate from NTFS permissions to Unix permissions or vice versa when extracting files. This can result in potentially unintended combinations, for example X files being created on NTFS volumes with executable permission denied. Versions of Microsoft Windows have included support for zip compression in Explorer since the Plus Pack was released for Windows 98. Microsoft calls this feature compressed folders. Not all zip features are supported by the Windows compressed folders capability. For example, AES encryption, split or spanned archives, and Unicode entry encoding are not known to be readable or writable by the compressed folders feature in Windows versions earlier than Windows 8. Microsoft Office started using the zip archive format in 2006 for their Office Open XML DOCX, XLSX, PPTX, etc. files, which became the default file format with Microsoft Office 2007. Legacy: there are numerous other standards and formats using zip as part of their name. Phil Katz stated that he wanted to allow the zip name for any archive type. For example, zip is distinct from GZIP, and the latter is defined in an IETF-RFC. Both zip and GZIP primarily use the deflate algorithm for compression. Likewise, the ZLIB format also uses the deflate compression algorithm, but specifies different headers for error and consistency checking. Other common, similarly named formats and programs with different native formats include 7-zip, BZIP2, and RZIP. See also, comparison of file archivers, comparison of archive formats, list of archive formats, LZW, references. External links, zip application note, landing page for PKWARE's current and historical zip file format specifications.